Okay, so we're talking exponential growth and decay. Here are your three key formulas. In this case, A or capital A is always the amount. Now, Y is going to be a total. R is always a rate. And N is a number of times. So if we want something that is growing, so for example, if we take a look at example 1 in our book on page 432, okay, if we do this as the prize for a radio station contest begins with a $100 gift card once a day, a name is announced, a person has 15 minutes to call, where the price increases by 2.5% for the next day. Write the equation that represents the amount of gift card in dollars after T days with no winners. So, what is the initial amount? A equaled what in that example? Does anybody remember? What was the amount? How big is a gift card? 100 bucks. What rate does it increase at? 2.5%. So here we go. Amount, $100, hundo. And R, now it says 2.5%, but can I put 2.5% into any math equation ever? No, why not? It's a percent. You got to turn it into a decimal. What's a decimal? 0.025. Why is it 0.025? It moves 2 spots. Does everybody agree? So you have that rate. So all we need is this formula. The amount it's going to be is the original amount, $100, times 1 plus 0.025, because that's how much the rate is, times T. Now, this, it goes up every day. So if this is my formula, $100, 2.5%, or 2.5% every day, what would it be after 5 days? Well, what would I put in for T after 5 days? T would be 5. And so all you do is say Y equals 100, parentheses 1 plus 0.025 raised to the 5. If I simply plug that into a calculator, are there any variables left at all? Are there any variables left at all? No. So all I have to do is say 100 times 1.025 raised to the 5th power. Answer is it's going to be worth $113.14. That's how much it's going to be worth. Now, let's go the other way. Let's assume, so that would be growth because it got bigger. Let's do one that says decay. Let's say you got a $100 gift card that you won, but every day you don't pick it up, they take a 5% discount. So it becomes worth less for every day you don't pick it up. Does that make sense? So here we go. Start with the same. A is $100, but this time you're going to get a rate of negative 5%. So what do I do for a decimal for negative 5%? Negative 0.05. It's because you move it 2 spots. So in this case, instead of growth, you need decay. Decay is where it breaks down, where it gets smaller. Like if you died and we buried you, you would decay, right? You would decompose. Same thing. What's the only difference between these two equations? Subtraction instead of plus. So Y equals 100 times 1 minus 0.05 raised to the T. Let's say you waited again 5 days to pick it up. So here we go. 100 parentheses 1 minus 0.05 raised to the 5. If I put it in my calculator, 100 times parentheses 1 minus 0.05 in parentheses raised to the 5 power. Answer is, now your gift card is only worth $77.38. because you waited. This one was growth. This one was decay. Now, that is just every day it grows. The other way to think about this is compounded. Now, compounded is kind of like the credit cards that we talked about. Let's say you owe $100 again on a credit card. And your rate, what did I tell you the rate yesterday was on a lot of credit cards? What did I say? 20%. What's that as a decimal? Move it 1, 2 spots, you get 0.2. All right. Now, if it's compounded, if it's only compounded once a year, you would say amount equals P1 plus R over N T. If we do yearly, how many times will it be compounded if it's yearly and done in 1 year? You would say once, because it's yearly. So you would say the amount you owe is the principal. P is for principal. $100. 1 plus, what's my percentage? 20%, 0.2 over once, one time in one year. And that gives me 100 times 1.2 raised to the 1. Answer is, at the end of the year, I'm going to owe $120. So I put it on a credit card, but it's a fancy credit card that only charges me interest once a year, $120. Unfortunately, that's not how credit cards work. Credit cards charge you every month, don't they? So $100, and it's 1 plus, the rate is still 20%. But folks, if it's monthly, instead of only charging you once in a year, how many times will they charge you in a year if it's monthly? Yes, sir. 12. So now we say 12 raised to the, and now instead of 1 here times 1, it's 12 times 1. So it's harder to put in a calculator. I'm going to zoom in on my calculator. I'm going to zoom in on my calculator here. And it's going to be 100 parenthesis 1 plus 0.2 divided by 12 in parenthesis raised to the 12 times 1. If I put all that in my calculator, I get, there you go. What happened when they charged me every month? What happened? Instead of 120, I got charged 121.94. I have to pay more because they charged me monthly, didn't they? Now, technically, credit cards don't charge you just monthly. They actually charge you continuously. But since you can't do continuously, let's go daily. Daily would be how many times will they charge you in a year? 365. So $100, 1 plus the 20%, but done over how many days? 365 and 365. Let's see how much that's going to be. And we do the same thing on second entry. And we'll change this to 36 second insert 5. 36 second insert 5. So I've changed it to be 365. Answer is 122.13. Why is it that the credit card companies are charging you more often on the interest? Because they want more of your money. Okay? So you have growth and decay, and you have compounded interest. And so the last one would be forever. Interest equals P times E to the RT. So interest equals the principal, $100, e to the 0.2 times t, and that's going to be for 1 year. And I'm going to say 100 times second e to the 0.2, enter, 122.14. So that is continuous. Now, you don't need to know this one because that's above your pay grade at this point, but that's where we're headed, okay? And that's exponential functions. So that's what you need to know for that.